Well, in this particular episode, we'll be continuing the implementation for the logs interpreter. And what we're going to do here is to try to implement some sort of class and instance object so that we can actually use OOP style code in logs. Up to the last round, what we have done is we tried implementing some of the base code in logs, and according to our test, we find that it returns a seg fault. And when we dig a little deeper into why the seg fault happens, we see ourselves getting the seg fault in trying to get a particular class over here. We're getting some constant chunk in VM223. So taking a look at the code there, we see ourselves trying to read some bytes from the constant chunk. And this is basically supposed to be the name of the class. So what byte is it trying to read? In this case, it's reading byte number 2 from the function chunks. But is it even written to byte number 2? We don't really have a string that's writing into it. So we have to write into it through our compiler. In this case, we need to write into it through our compiler. So in our compiler.c, what do we do when we do the op class? We try to declare a compiler and then try to put it into a class declaration. I have a name constant. This is supposed to go into the variable. But because of this identifierConstant is being run, we are actually writing into the global values. So if you actually hide this, and instead to take from VM I say take from here. Build. And we will still run into trouble here because the global object is not defined properly, but it's not the same error anymore, right? So there's a few things we need to figure out here in order to properly implement this. Okay, what are the things that we need to properly implement here? Right. Now, what do you need to properly figure out? Right. So we need to figure out things like what is supposed to be in global, what is supposed to be in chunk constants. Okay, so why am I failing here? Because probably in debug, say I want to object.c print object 86 object.c. Okay, as class value. Okay, value. Do you think I have value? No. Class name as class. Okay, so looking at object.h, what does a class have, right? What does a class have? I have an object string pointer called name, right? Which when I create my new class, I'm supposed to point to. Okay. So let's try to break it a bit so that when I'm printing here, so where's the error, right? Error is in object.c, not in new class, but in print object. Okay, let's put breakpoint here, object.c86. Run the class again. So here, if I try to print value, I will see that I have an object. And this object actually points to something. And if I cast it as a string, no, object class. What if I do as class? Okay, let's try. No, as class in the context is okay. I'll cast this as a class. Pick inside. Then my name is not set basically. And why is my name not set? Okay, so let's now break on 147 of object.c. Object.c 147. Okay, after this it should be set, right? So let's run the test again from the start this time. I noticed that I pass in a now pointer right here. So who is creating this new class? Who is calling this new class? And it's called in vm.c 226. So we're going to vm.c 226. Because it's not inserted into the thing as a value properly. Right, so there's a few things we want to do here, right? So a few questions that we want to answer. Do I want the string to be in global? The string that is passed. Do I want it to be local or constant? Actually, it could be in two places. So what are we actually doing here, right? So in compile.c, in class definition, what are we doing? Right, we are trying to, let's see whether we got the code correct, right? What is identifier class then supposed to do? Right. It's supposed to go into the, supposed to create a string, make sure that the string exists in global names, right? Maybe we forgot to push. Is that the case? Right, global name never really push onto the global value, just do undefined. So where are we supposed to set this then? Did we lose something along the way? Okay, string. So here we are in the vm.c. Let's see what we expect to do, right? We expect to create a new class from the string. So we expect to be storing the string in global.values, right? So let's add sorry. Let's add an additional step to declare variable, name constant, define variable. Let's define variable min. Not initialize. about this. I'm just going to output this define global, which is correct. This is a constant. Is this correct though? Undefined value. Maybe this is wrong. Okay, new check. This is correct. But we could very well be wrapping it in a var object string. Is this what they want? We are not that sure, right? What is this supposed to keep? Object var. Object value string. Okay, let's try. So now instead of just not looking anything, I put the string into it as a default. Don't know why I'm doing this, but let's just go for now. Which seems correct. Why? So we ask ourselves then why we need the undefined. Okay, so why are we inserting undefined into global values? Right, so how do we tell? How do we tell that we are doing it correctly in this case? So looking at okay, I want to find out where undefined is. Undefined variable. Undefined. Okay. Where would I need undefined value? Where do we see undefined value? I don't even see it much actually. Let me think. See, I am looking at compile.c. And I'm looking at the function identifier constant. Identifier constant. And let's copy this over here. Okay, so we have found the source code, and it looks like we don't actually have. So if you look at identifier constants, it's just a makeConstant on object value copy string. So makeConstant is just an add constant, right? So where did all these token string come from? Copy string, token string. Identifier constant. Let's check whether undefined value even appears at all. How do I check this? Okay. I can actually pull it, right? But I don't want to do that. So let's take a look at where undefined value or object value is. This is in value.h. We don't really have wait, wrong, object.h. Where is my definition of define object value? Object type. No, value.h. Is there undefined bool? There's an object val, a number val, bool val. Okay, we don't really have an undefined val. And the expectation here is that we are putting the string as the val. Is that correct? We can do it for now. Let's just keep it for now, right? To do, figure out where undefined val came from and how it's used. So let's put a note here. We need to figure out how undefined is used. Okay, so how do you do that? Code check, right? Undefined bound. Is it used anywhere? It's not used anywhere. It just is a special type, but it's not really used anywhere. How about is undefined? vm.c. We do check for undefined. Right. Therefore, okay. So because we check, we do want it, right? So here we want to change our implementation a bit. So in compiler.c, undefined. We do want the undefined, and want to explicitly write. Right, what? Token string name, right? Assuming that it will be the same. Okay, so identifier constant. Actually, it's a bit wonky, right? How does undefined works? It's a bit wonky. Okay, so we want to set something, right? Value array. The way the first two is written is not undefined. So there are only a few ways things can be written into global values, right? And if you see here, things get written in the global values only when we are setting stuff, right? Set global, things like that. So I think it's a hacky that we are relying on this string to be there. If you really want, we need to do add constant, right? Okay, so let's do it the way we think is supposed to be correct. We have add class, right? Make constant. Make constant value, right? Make constant value. So class identifier constant. I also want a string. I ultimately want a string. So what I'm going to do is to put in a string from somewhere and add that as a constant and make that be used. Oh no. Should it be here then? Identifier constant. The original code, or does identifier constant do? Compiler.c. Okay, or does identifier is basically just a make constant of a string. This function looks wrong, right? I'm just making function of a string. Identifier. What should this return? This should return a makeConstant variable. Define variable. I don't think the implementation for identifierConstant is correct. Don't know what I'm doing here, but let's make it the original one where I'm trying to make constant from object var token string. So make constant object var token string. Okay. Okay, identify constant. Why are we doing all of this? I don't see a point. Let's see whether anything wonky happens if we do this then. Oh, so it's a native function. Okay, this is weird. Okay, so I can't do that because now the values get shifted. There's a underlying expectation of okay. Never mind then, let's just do this. Out class. I don't think it should be a identifierConstant, but actually a makeConstant from a object value token string partial pass. Yeah, let's see how this works. Okay. Build.sh undefined variable. What am I doing here? Object class native function, that is wrong. I do need it to be identify function. Actually, what's this doing, right? I assume that this stores the string, but it's not anymore. That's okay. This is a bit wonky. Okay, let me think through this. What am I trying to do here? This has a undefined. Okay, let's just to do fix undefined. Okay, I guess for the sake of moving on, let's keep this in this way first. And once we decide where to do, re-implement undefined value. Okay, so we just write the strings and go on with it. So build.sh, run my test. Just for confirmation. Okay, all right. So that was that. We need to redo our undefined value implementation. Okay, then let's move on to 27.3, which is where we stop. Instances, right? Continue with 27.3. So instances, so object.h. Create a new type dash struct of object instance. Oh, that's pretty smart. Same object class, star class, table. Oh, how would they know that? Okay, table fields. Okay, so I don't really have a table here. So I need to go up and include table.h. And table in this case is just a map, so that will map what values we have, which is basically the attributes of the class. And in here we want to add one more object instance. This is explaining a bit of how OOM is supposed to work. Then we do our hacky functions. Then okay, nice. Then okay, I have one new function object instance star new. Okay, and then in object.c here we will do a new instance function. Okay, I have a class, so I need to set the thing object instantiation. Okay, I set the class. Then I init my table with the fields. Okay, that's all very good. And then we have memory.c. So now we have a new instance class So it will free itself. No. Other than freeing itself, we also need to free the table. So let's cast it to an instance object. Then after that, we want to free table on the field table. So when we actually pass in the thing as part of a memory, we also need to do some stuff there. So object instance. Okay, so I mark it as an instance, cast it as an instance object. I mark the object class. Actually, I don't really need to cast. So screw it. Then after that, I want to mark the table. Okay. So object.c in the print object. Case object instance. Okay, is instance class char character. Okay. Okay. So vm.c call value. So I can call a class object now, and that will create a instance, right? Yes, class. Okay. Okay, whatever. Okay, so here I have a class. I insert into the okay. Okay. So when I call the object, I call a function, I update the stack to replace the last thingy with an actual object value and return true. So actually, where is call value used, right? Call value is in opcall, right? So we can actually now call an object and then expect to see something different to return an instance, right? So let's see, okay, build first. Seven. Okay, that's right. For now, that's all right. Okay, so get and set expression, right? We want to okay. We want it to have a dot operator. So what do? We have to expand our syntax parser thingy, right? So token dot. If it's infix, I will call a dot function. And what is a dot function? So a dot function is something I need to write. So here static void dot function boolean can nope, not gonna help me. Yeah, okay. So I expect proper name after that. Okay. The name is identifier constant. Okay. if I can assign and the match is, I do expression and I do set property. Okay. Else what's this left token? Oh no. Okay, I don't want to do this, whatever that is. Okay, so if not, I do get property. Alright, it's either a getter or a setter. So we have to then, okay, these are just okay. So okay, some gotchas here. Gotchas. We only want to set when can assign because of equal passing. Because of the parsing of the equal sign. E.g. a plus b dot c equals to 3 is wrong. Okay. Note here. Okay, so we are going to our chunk c of chunk dot h get property set property, and in our debug.c we should print them out properly as well. Constant chunk, is it global? Hard to tell. So false for now. I don't think it is. Okay. Okay, set property here. Okay, so let's try to, okay, one more. How do we actually implement it, right? vm.c. Okay. Okay. This is supposed to be in run. Oh, when I get a property bytecode, what do? I mark the instance as instance. Assuming correct. Okay, so sure, let's put this in, right? This name I read. Then after that, I create a value. I check whether the value is in the fields. And if it is, I replace the instance. Replace instance with value. Break. Okay. Then okay, I don't really do this because I can just do it here maybe. Return interpreter runtime error. Okay. So this is what missing fields. Define property. What do I say? It's quite smart. Okay. Let's do this. Case. Okay. Checking the instance. Second one. Whatever I want to set. That's the field. Value pop push. This is the value I want to set. I pop it out. I set the value, pop it out, the instance, I pop it out, I push the value onto it. Okay. Set property will return the value that is set to. Okay. Same thing. Let's see whether we can get our test to work. Okay. Let's see. This is some weird syntax. Let's test if this works. Okay. Line 1, 3. This is weird. I don't really expect at the pass. Error at dot expect of the value line 3. Equals to error at dot. Okay, let's see. Did we do it wrongly here? This is just implementing on the fields function. And let's see. Oh, right. It's called. If it's postfix. No. What's this? Oh, what do I call after? Okay. What do I call after? Okay, sec4. Nice. Unknown opcode. Strange. Okay, let's look at the opcode generation. Do I actually push? Let's see. So it's all get operation. Okay, what's my code? Get up value. That's strange. Why I have get up value? Okay. Test. 7 class 2. Class A equals to A. Let's look at the syntax again. We need a var here. A dot A equals to 1. A dot B equals to 2. Print A dot A plus A dot B. I got a class, I define the class, I call the class, I define global, I get global, I set property, okay, up constant, it might be 1. So I set property, up con, get global, A, constant 1, 2, I set A as 2. Okay, let's change the name around a little. C and D. C and D. Okay, looks like we are not getting it right here. Okay, so I think identify constant might be the wrong thing to use here, given our change in code. But what is it actually trying to do? I think in this case it's trying to just make constant. So let's actually just try make constant token string parser previous. Okay. Okay. You okay, define global. Okay, A. It's a string A. Opcode set property set to string C. I call get okay A C set property on C. Okay. Then I get global to set property of D. Pop. I global A get property of C, global A, get property of D, add and print and new and return. Okay, so this opcode generated now is correct. The problem now is there is a floating point exception. So let's take a look at what is going on there. Hey, nope, I didn't want to do that. Let's try again. 7. There's a arithmetic error. Why is that the case? Why is the arithmetic error? It's in here. Key, print key, hash. Mod 0, capacity 0, right. That's the problem here. Table find entry. Okay. Okay, if capacity equals to 0. Okay, let's do a check, right? Just a check here. It's a bit silly, but let's just do this check. So it might give another error. It's still an error, right? Means our VM side is not doing it. We are not setting it properly here. So running with the test. No, it's sec fault. Nice. So let's log again. Test 27 class 2. I'm trying to set something, right? Table set. Print entry. Entry is 0. What am I doing? What am I doing here? Okay. vm.c. Okay, so we can get the right opcode, but the VM function seems wonky. Okay, and what is the opcode? Okay, for this script, the opcode is here. There's a few main components, right? is up to here is creating, okay, up to here, get global one, C set property pub, this is one, set to pub, this is one, C and this is one, print return newest. Okay, for this piece of code, this seems correct. Right, exclude test 27. Okay, so what are we doing here? vm.c251. Table set. Okay, so let's run a stop on this function here. 250, right? 250, vm.c250. Breakpoint vm.c250. Run our test. Okay, what's going on here? New line. Next. Instance fields. Nothing, right? So table set. I have pick 0 2. Pick 0 is a variable number with object. Or is a variable number 1. Okay. And read string. Oh, okay. So is there a way to increase table size? Table adjust. Okay, say I see. Our combined thingy is coming back to haunt us. So before we do a table set, we need to do a table adjust. Instance fields 1. Okay, setting instance dot 1. Okay. Why? Let's look at definition of table adjust. If I grow too big, I will shift the table and set it accordingly. Did I point to a correct table? Let's find out. Oh, yay, it works. Okay, so here, okay, here. Okay. Okay, so let's see what do we have here. Okay, let's see what do we have here for now. We implemented class, implemented some ways for it to get the variables attributes in the class. We found an error with undefined value. Implemented dot, new opcode, new class, new instance. We fix a few bugs somewhere. Okay, let's see whether there are any debugging prints. All right. And there's one there, we don't really care about that. Okay, so let's double check now that it runs. Okay, so as to our 25 closure, it runs. 27 class. 2, it runs, and it looks like it's all goody. Okay, so yeah, implemented class chapter 27. Okay, with that, let's go through a bit of what we did today. So first, we found some bugs in the way we do our identifier constant. So there is some to-dos here actually. So let's list the to-do downs in the file itself. So identifier constant. So a to-do is fix this, and also to-do okay, visual, when to use identifier constant, when to use makeConstant. It sounds like a specific subclass of stuff, so I don't know. Right, that's something that I want to find out. Then we also found that the way we implement the undefined variable value that's a bit wonky, doesn't really work well with the current code, so we have to work with that. Then we implement all the class stuff, instance stuff, and we get our opcode for setting and getting properties. And we tested it and it works, and we are very glad that it works. For the next time, what we're going to do is we're going to go through some of the challenges. All right, reading quickly here. We may want to missing field. What do they do? Right, fields accessed as runtime by the string name. Right, technically you can if you objectize everything. No ways to remove a field. Okay, how do we remove the thing? Fields access at runtime. Right, how do we deal with slow runtime due to the fields? Okay, so those are some things that you might want to explore next time. Okay, challenges, how to make class and instance fast. Okay, with that, that's all we have for today.